Hey everyone, thank you for joining this session. I'm Rejeesh, VP of Engineering at Ashling Microsystems, and today I'm going to speak about, cover a bit about our new feature. It's the AI-driven real-time RISC-V embedded application debug using our tools, using our debug tools. And in this case, it is Vitra-XS debug and trace prop. So before we jump into that one, I'll just give a quick intro of who we are, what we do. And yeah, we are a company founded in 1982, like 40 years plus, and we are headquartered in Limerick, Ireland. We have the engineering offices both in Limerick, Ireland, and then Cochin, India as well. Sales globally, we have offices including right here, and we always have been a member of RiscFree International. We are talking RiscFree here. And about what we do, like essentially we provide debug tools, and we do both products and services. When it comes to products, essentially whatever is required to debug your system is all the way from SDKs, IDEs, debuggers, compilers, hardware debug and trace props, all the solutions. And of course, we provide engineering services as well based on our expertise in the embedded domain. And yeah, not just debug tools, we do even other hardwares. Like you can see on the right corner, you can see an emulation platform we did for an XP chip. And the other is the debug devices which we provide. So you can see the Ashling Vitra-XS on the right side, which is our flagship product for both debug and trace. In fact, I'll be using that particular product today to show how this AI-based debug is going to work. And then Opala XD and Opala LD, they are the JTAG-based debuggers from Ashling. And on the left, you can see the Eclipse-based RiscFree ID. In fact, we have VS Code-based solution as well. I'll come into that one. So I'll be using this RiscFree ID plus the Vitra-XS debug and trace prop to show you how to do this AI-based debugging. And yes, I'll just give a quick intro of this RiscFree ID and the Vitra-XS before I go into the actual debug. RiscFree is, again, it's a commercial, a professional commercial grade development kit, development tool, and actually it has both two flavors, both the Eclipse-based solutions. So Eclipse has been the go-to framework for years or decades now, and the recent trend has been the VS Code. So we do provide the VS Code extension as well. So it depends, it's up to the end users to decide whether what flavor they need, if a VS Code-based one or an Eclipse-based solution. And yeah, it's a single shot installer, so it comes with everything what is required, like the tool chain, the build tools, everything comes in a single shot installer. So once you install the tool, you can start using the tool straight away. You build your application, download your application, and start debugging the application. That's the way it works. And we do support, heterogeneous debug, and that has been the case from day one. Like the simultaneous heterogeneous multi-core debug is one feature we always supported. So what that means is that if your SoC, it has maybe a RiscV core and an ARM core, or maybe a RiscV core and a Synopsys Arc core, you don't have to be switched between your tools or the IDEs. You stick onto the tool, what we have from us, and you should be able to debug all the architectures. So kind of an architecture agnostic solutions. And yeah, there are some advanced features like, RTOS aware debugging. So if you're developing an RTOS or maybe porting an RTOS, like all the insight, like, what are the tasks running, what are the events running, which task created, what event semaphore mutex, what task is waiting for which mutex, those kind of things, and advanced features as well. I'm not going into details of everything. I just want to give an intro of this RiscFree ID from us, or the SDK from us, which I'll be using for the demo. Next one is the Vitra-XS debug and trace probe. It's a flagship product from Ashling, where you can do both the JTAG-based debugging and the tracing, the real-time non-intrusive tracing. Again, I'll be touching upon that one. Sorry. So again, the key thing here is we can call it as an architecture agnostic solution. So what means is that irrespective of the ISA or the architecture you're using, whether being a RiscV core, ARM core, Synopsys Arc core, we have it covered. So this single box can support, all the architectures, what we're talking about. And when it comes to trace solutions, again, different architectures, different protocols. Within RiscV, we all know that we have the Nexus trace and the E-trace. Both of them are being supported. And when it comes to the other architectures like ARM, we have this ETM, PTM, STM, all those kind of things. And from Synopsys, we have this real-time trace, RTD trace. All of these are supported. So that's the one key thing, kind of a universal prop, which should allow you to debug and trace anything. And again, simultaneous heterogeneous tracing as well. So that's on the Vitra-XS debug and trace probe. And this slide should actually give you a good idea of how much of insight you get into your program, using this Vitra-XS and RiscFree. Just showing you some of the highlights here, like the one you see on the top, what we call the function flow timeline view. It gives you a complete call stack at any point of your debugging. So you run your target maybe for 10 minutes, half an hour, one day, you still have your call stack, the entire call stack of your application. So if you're someone looking into the exception happening or something, just look at the call stack. You can zoom in, zoom out, whatever you can do and see what exactly was happening. Likewise, we have the function profiling, very familiar, should be very familiar with everyone. Like, you get the information like which function took the most execution time, or maybe like which function where the code is being most executed, a kind of hotspot analysis. And if you are trying to optimize an application, just this view alone should be sufficient to understand the function which we should be focusing on to improve. And yeah, we have the code coverage view as well. Obviously, what we see in the screenshot, it explains how it works. It will show you what piece of code is covered, what piece of code is not covered. It even gives you a code coverage summary. So that summary, like, okay, from a function perspective, number of lines being executed, number of lines being not executed. From a file perspective, what is being executed and what is being not executed. So far I've been, talking about the features, showing you screenshots, and this one is actually a real video showing how things are working. Obviously, I cannot take my whole tools here to do the demo, so that's why I have the video over here. But yeah, we are actually G1 right across there, so you just come over there, you should be able to see all these things in action. So what this video I'm going to show is that, the real non-intrusive tracing. So when we say non-intrusive means the trace tool will not be halting the core or maybe affecting the frequency or whatever. The core will continue to run, so we can use this in an actual production scenario. And I'll just start the video and then explain, like you can see I can now running the target. So now the target is free running. Without halting the target, you can see the trace views being updated. You can see the function flow timeline being updated, the function profiling view being updated. So the point is that core continues to run and we can see all the trace data. So assume like you were again, you had a segmentation fault or something happening in a production scenario, maybe overnight. You run it for 3-4 hours. You can never debug and find the issue. In that case, just have this streaming setup ready here. We call the streaming feature. You can even see the buffer storage. I'm using a 10 GB storage here. So you are not limited by any storage size. You have a 10 GB storage here. It can be 100, whatever. You're just limited by SSD on your laptop. So you just have the setup ready here. Just freedom the target, go grab a coffee, just come back and check, okay, if my program is still running fine, if it is still in the call stack, I know, or if, an exception is taken or something. So that's how powerful this tracing is. Clearly non-intrusive, and, there is minimal effect on we developers. Just look at these views, the core is running, understand what is happening. So that's about this video. And now I'll cover what I really want to cover here, this AI-driven debug. So what it does is that actually it's the next level. Whatever we have right now, even those are not required. The coffee I was talking about, you grab the coffee, just let this LLM engine, we call it as a TraceLLM engine. So this TraceLLM engine does all the hard work. We run the target, we get the trace, and then we have this a single menu item. Click on the button, get this TraceLLM engine up and running. You could just ask any questions in the natural language, the same way any ChatGPT or whatever works. It's a prompt-based engine. You could ask about your program execution. Hey, which function took the most execution time? Show me the code coverage. Where is the code executed? Show me a min-max table. Those kind of things can be asked. And it's all seamlessly integrated to the RiscFree idea I was talking about. So again, I have a video on that one. So I'll play this video and I'll show the whole sequence someone will have to do to use this tool. So here, when I'm playing this video, you can see actually I'm running the target. I'm fetching the trace there. So we have the trace data now being fetched. And now I just go press a button there. So pressing that button, we have this new prompt, TraceLLM prompt coming here. Here I can ask any questions about the execution. So I'm asking here, okay, this getChar function, how much, what is the call stack when this particular function was called, and show me details on that particular function. So you can see this processing happening in the background where you can see the processing has already been completed. It's showing the call stack of when this particular function was called. It'll give you more details, why this function was called, and how many times the function was called. So you can see I'm asking another question here. I'm not sure if you can read that. List the functions which does have 100% code coverage. So you don't have to know anything. Just ask the questions in natural language, and you get the output there. Okay, these are the two functions have 100% code coverage. So someone might be working on Fusa or something, or maybe unit testing or something, and to ensure you get the 100% code coverage, this is sufficient. And of course, there are more questions I could answer based on this one. You can see I'm not putting all the videos over here, just some snapshot of different other outputs. It's all reliable outputs, okay? I want to know, okay, how many times one particular function was called. Show me a function table, with the arranged in the code coverage order piece of functions being executed, the top functions. One question I asked is top functions with the most execution time. So if someone is working on the optimization, this is going to help him or her. So that's the idea of TraceLLM and how things are working. Obviously, I have my limitations with this 10 minutes to demonstrate everything here. But importantly, we have everything set up in our booth here. It's a G1 right across there. Whatever I have spoken here, this TraceLLM engine, the real-time tracing, non-intrusive tracing, we have all set up in our booth. So do visit our booth, and then happy to explain you how things are working. And of course, we're looking for more even collaborations, how we can take it forward. Thank you. Thanks, everyone. Bye.